And coming to the ERP systems, or even when you want to integrate with the other like CRM or financial systems, we cannot directly integrate. For example, take a simple scenario. So if I want to integrate with the parts master or a products which are defined in ERP, right? Or if I want to integrate with the supplier to settle the transactions on the blockchain, the suppliers will be a huge number, right? Look at like the kind of concepts like account receivables or account payables. The accounts receivables and payables, there will be a huge number of people who are actually working on settling those on a daily or a monthly basis for the organizations. So if you are bringing those onto the blockchain, right, we need to have a kind of a mechanism where you can bring the supplier master data into the blockchain, and you need to have that synchronization mechanism on daily basis. Otherwise, there will be a lot of data inconsistency issues. So how are we solving that problem now? Is we have created a layer on top of the blockchain. For example, if you're using Hyperledger Fabric, there will be a layer which is written on top of the fabric, leveraging the concepts of the traditional data lakes or the data warehousing, where the data on a daily basis or on a trigger basis comes synchronizes with the data that we are using it in the blockchain, right? So the decentralized applications, where they do is they talk to these the intermediate layers with the APIs and the data storage that we have along with the blockchain transactions. That's how we are right now solving the problem of non-availability of integration points. And the other concern is definitely on the cost of storage, because let's take the example what I mentioned. We are having a separate proxy layer to do these operations. Right? When I say the proxy layer, again there is an additional implementation, and we need to have a separate maintenance for it. We need to have a separate data storage for my for my data lake or warehouse, which can be available for my dApps. Right? So that is a concern. Again, the concern is also from the scalability point of view, both the blockchain side as well as the layer that we have developed it. And again, alignment with the regulations is also another important criteria to make sure that we align with the regulation standards, especially for the respective vertical. If you're doing it for the healthcare, so you need to have some kind of HIPAA compliance, or if you're doing with for European clients, you have to make sure that you are aligned with your GDPR policies. So that is important to make sure that overall platform when you are building it. So that's on the integration side from the enterprise application. Okay, so I forgot one very important point here is, so definitely this as you know that as we saw in the previous session as well, the blockchain is going to disrupt how we are going to use in the various enterprise applications. So that is the reason, if you look at from the companies like SAP, they are coming up with the blockchain capabilities to integrate with the ERP. So if you take SAP Cloud as part of their Leonardo offering, the blockchain definitely is one of the core service that they enabled. If you look at the roadmap of SAP a couple of years back, and if you look at within the last 2 years, you will see that there was no blockchain, and you will see definitely there is a blockchain presence. And in the overall the cloud service offering they are doing with the Leonardo platform. So that clearly indicates that it's not like the blockchain is not disrupting. They clearly, SAP clearly knows that okay, they need to adopt blockchain. Otherwise, slowly they may not be into the ERP market itself, right? So people can build a completely decentralized application on the blockchain and provide as a service. So to have their existence into the market, they need to adopt the blockchain as a technology. And now we clearly see that as part of their Leonardo ecosystems, right? And take the examples of like from the scalability perspective, when we saw in the morning session as well, companies like Storj, Filecoin, they completely rip the document and then store the pieces of the documents in multiple places, right? In whoever part of the IPFS network. And when you call for the document, they combine all that and give the document to you. So they are working on how we can provide that the scalable storage from the storage of documents, or it can be any document. I say document, it can be not just a Word document or a PPT or a PDF. It can be your JSON document itself, right? So that's how the companies are working in these areas. Okay, so let me go quickly for the we have of time. Okay. So the other important element now I want to talk about is on the overall programming languages. So when I say the programming languages, right? Just give me 1 second. Huh? Right. I see some disturbance on the background, so just I will close the door. I need to just close the door so there are disturbance. Okay, sorry for that. Okay, so let's discuss on the platforms and programming languages. So if you look at building, let us say I'm using Hyperledger Fabric. I need to build the overall deployment of my application on the network. What it means is I need to build the smart contracts. I need to build the decentralized applications. So when you are building your smart contracts, so you need to write as per the languages they support. For example, the good thing with Hyperledger Fabric is it supports on multiple languages which we use on a regular basis like Node.js, Java, Golang. But whereas in Ethereum, you cannot build smart contracts in any of these languages. So you have to leverage either Solidity or Viper. Right? Viper is also very recently announced, and Solidity is what a completely new language that you need to learn. And it's not the same as writing your traditional programming languages for writing your contracts. Right. Okay. Hello, are you able to see my screen still? Okay, let me check. Okay, fine. So I think my second screen got dropped. So so let's look at from the languages perspective, right? So let me get my so from the Ethereum smart contracts perspective, you have to build again in the Solidity. So remember that the writing the contract is not same as writing your traditional programming language. You need to keep a lot of things in mind, especially when you're writing contracts in Ethereum side. So the storage is going to be very important. You need to consider like who can access the permissions of every execution of your method inside your contract is also very important. And on the same lines, when you're writing in the Hyperledger Fabric, you need to consider how the contracts for which channels the contract is, how are they going to interface with your contract, how is my contract to be upgraded, right, from one version to the next version. So those are very important elements that you need to keep it in mind when you are building your smart contract. And one of the I can say the biggest barrier is also the languages that you need to learn. So you need to separately learn a new language itself. For example, if you take EOS, right? EOS is another blockchain where you need to write the smart contracts in C++. It's actually not same as C++, but very similar to C++, right? So language barrier is definitely one of the biggest I can say challenge in adopting the blockchain as a technology. So in order to overcome some of these challenges, the various cloud players are coming into the picture. So if you take Azure now, Azure provides blockchain as a service. So what are they doing is they enable to write your contracts in C#, right? And then they deploy that contract into the Ethereum. So Ethereum will be your underlying technology running out of Microsoft Azure, and they enable that as a blockchain as a service for you. The same thing applies with IBM. So they enable blockchain as a service and start providing the interface points with various other services available as part of their network. So that's how they started started looking at leveraging the existing ecosystem what they have in the cloud along with the blockchain as a service. So I can see there's a huge evolution happened in blockchain as a service, both across all these cloud providers. You name it, all of them has now blockchain as a service now, including SAP. So they have blockchain as a service from their cloud. Okay, so that's it. And if you look at any new players in the blockchain now, in the blockchain, like for example, Neo. Neo is also another. I can say it's the same as Ethereum, but they have rewritten the complete Ethereum in .NET, right? So they enable writing your smart contracts in C Sharp as well as in Java. So now the many new blockchain platforms enable writing your contracts, interfacing with the blockchain in various languages. Okay, so that's about on the platform languages, right? So let me go to the next one. Let's touch based a little bit on the IoT with blockchain, but I can also say that sorry, I am on I'm on mute. Okay, so sorry for that. It got disconnected. I'm not sure. It may be because of the network. Okay, so let's come back to the blockchain for IoT. So the blockchain brings a trustworthiness for the overall IoT ecosystem, right? So look at from where we can use the blockchain as a technology. So what we look at right now, you can actually run complete IoT ecosystem without blockchain. But with blockchain, what additional thing that you get is I can say your device registration process. When a device registers itself, you can have the information on the blockchain, so that the data itself is the registration of the data of your device itself is highly immutable. So that's there. Or you can go with IoT and uh, registration process one in the blockchain, but people are now looking at leveraging both IoT and blockchain in hybrid mode. So most of the implementation, what I see from the future point of view is in the hybrid implementations. That is one. So let's look at the next concept, which is called crypto anchor. So the crypto anchor is a concept. I guess it's from IBM, whatever I can recall. So what IBM has done here is which is right now in the research phase, and I can definitely see that is going to be the way how the things are going to change both IoT and blockchain together. So what it does is it gives you a unique identifier for your devices. So when I say unique identifier for your devices, it can be based on various parameters. So when I say various parameters, is based on the your device attributes, or device properties, or device surface can be considered to come up with a unique identifier. So this unique identifier can be used to find out the authenticity of your product, and nobody can replicate this ID. Is what the crypto anchor is going to provide. which is again leveraging the concepts of your blockchain. So you can look at in the IBM research, or you can pretty much understand how exactly this crypto anchor and how they are working on it, which is in the research phase for now. So the next is on the blockchain as a service. I guess I already talked about it. So for example, if you take Azure, you can build your smart contracts and deploy that on the blockchain as a service in Azure. It can be Ethereum based or it can be Hyperledger based, and you can take your devices can be registered onto your blockchain. That is like having you as one of the user onto your Active Directory, right? Your device also will become as a user onto your blockchain platform, and they can provide complete telemetry data and then store the data into your network. So it again, you can take a call whether to keep all the data inside the blockchain network, or you want to keep only the certain things in the blockchain. So for example, we did in some of the case studies where we don't store the telemetry data coming from IoT into the blockchain, but we store if they cross any thresholds. For example, when I'm shipping in the cold supply chain and they need to maintain a minimum of 20 degrees centigrade, right? And in the shipment, if it is above 20 degrees, like 21, 22, then that is above our threshold limit. So then that entry with the timestamp is what we store it in the blockchain. We don't store remaining data which we captured from the blockchain. So that way I can reduce the interactions with the blockchain, and the remaining data can be stored in the off chain. So you can take a call on how best you can come up with your data storage strategy when you are implementing the blockchain for IoT side. So let me go to the next one. Last but one slide is on the quantum computing. So you might have heard there is a huge amount of hype again on the quantum computers. I strongly believe that the quantum computers will take at least another 5 years to come up in the enterprise uses. It's not for the public use. So the big enterprises, if they want to use it, they can leverage that. So it's in the initial research stage, like the IBM, Microsoft, even the Honeywell. They're pretty much having some of the working models, but very minimal qubits, right? How exactly this quantum computing is different, and why we need to discuss quantum computing in the blockchain. So that is very important, right? There are a lot of people keep saying that, okay, once we have the quantum computers, the cryptographic algorithms that we have in the blockchain, they can be easily manipulated, right? They can from by using your public key, we should be able to regenerate the private keys, which is definitely the problem. But yes, you can definitely say that the quantum computers, if they come for everyone's use, that is definitely a possible case, but it's not in the uh, sooner time, right? So what is the difference between a quantum computing and the regular standard? Regular standard we always will be in ones and zeros. Your atomic value, it can be 1 and 0. But whereas in quantum computing, at any point of time, the atom can be in either of the states. It can be 0, 1 or 1, 0. Right? So we call that as a qubits, right? And then qubits will have something called entanglement between like two qubits can come into an entanglement, and this entanglement can even exist the geolocation difference of countries as well. So that's pretty much possible. So what I will suggest here is these quantum computers. So somebody says that, okay, no, the blockchain algorithms can be easily manipulated with quantum computers. Don't believe that. It takes time. It's not that easy to get that breaking the current algorithms. So that takes actually, if you take the cryptographic algorithms, what we have in the normal computing power, it takes the time of the universe which is formed. Right? It's not that easy. But definitely with the quantum computing, yes, there is a probability, but people are also looking at, there is a concept called lattice-based cryptographic algorithm. It's again from Microsoft research. So Microsoft has almost done almost like 3 years of research in coming up with an algorithm which is available right now. So we call it as a quantum safe. So one of the blockchain company which has already started using that called as Neo blockchain. So they have a concept called Neo QS, which is called as like quantum safe. QS means quantum safe. And during this research, when I'm creating this slide, so I don't even know that there is something existence called QRL. So the first time I even noted down this week only called as a QRL. Then I spent a good amount of time in reading about it. You can also go and look at it called qrl.org. So what they have done is they have created the quantum algorithms, which they are saying that even the quantum computer cannot break those break those cryptographic algorithms. So that ledger is called as quantum resistant ledger. The QRL indicates quantum resistance ledger, and you can spend some time and then read how are they doing it, because not spend much time, but looks like they have the test network also available from the blockchain perspective, so you can spend some time there. Okay, so let me come back to my final slide. So I will give you at least some time this time to ask more questions. The final slide is on the convergence of technology. So I'm a true believer of saying that the blockchain alone cannot solve all the problems, right? Or cannot be the only the technology that can be used for enterprise use cases. It should always coexist with other technologies. So, like I believe that the technology of blockchain, IoT, and AI, if we bring all these three together, that's where actual disruption starts. So, how do I say that? Is blockchain brings the trust, and IoT brings the data for us, and machine learning brings the predictability. Right? My models can predict what is needed. So, if you look at the existing traditional machine learning algorithms that we are using, or the data that we are used to train those models, right? We can say one way it is biased. So there's a lot of debate on that, but definitely it's a topic of debate on whether it is a biased model or not. Right? At the end, it is built by the humans, and we are training those models. So based on the data, what is available, right? So there is a chances of having a biased decision. But if you look at bringing a trusted data from the trusted things, which is IoT, and having a prediction based on the data which has more value than the biased trained data, will give you the better insights, right? Better decision making for the enterprises. So that's where I believe these technologies together, the convergence of these three technologies, is where a true, I can say, value for the enterprise applications. Mm, and you can look at, there's a huge amount of possibilities. So one of the project which we are working from almost like last 2 years. So I'm driving the project which is on the Singularity Net. So you can go and look at in the website called singularitynet.io, or you might know about a robot called Sophia robot that is from SingularityNet. So we have built a complete AI marketplace on top of blockchain. So where we are leveraging these two blocks, right? Blockchain and artificial intelligence. So we have like I can say 50 plus AI algorithms running on top of the blockchain marketplace, right? And having seamless decentralized capability compared to any other traditional cloud providers. Right? Cloud providers, they will be the owner of your data, but whereas in the decentralized, you say what type of algorithm that you want to use and what type of data that you want to use. So that's where the artificial general intelligence comes into the picture rather than the traditional AI. So look at these three technologies together. That definitely gives more and more value for the enterprises. I think with that I want to conclude uh, on the presentation part. So we'll move to the questions. Last time also not given much time. I just gave only 4 minutes questions, but now I will open to the question. Maybe for both the sessions you can ask questions now itself.